Okay, so here we go with 8.2. We're going to talk about parabolas again, and let me just review what we've had so far, because in chapter 1 we saw the standard form for the equation for any quadratic looks like this: ax squared plus bx plus c. And that gave us our parabola when we graphed it. Then we also learned this standard, this is standard form, but we also learned vertex form. X minus h, something like this, plus or minus like a k sitting over here. And the vertex was like h comma k. And so we also learned how to complete the square and all those fun things. So the interesting thing is, you might say, well, why are we learning about parabolas again? It was because parabolas actually have interesting characteristics that we haven't talked about yet. And we're going to learn about two of those characteristics today. And so a parabola also has what's called a focus point. So if you were to graph a parabola, we've seen in the past that they have an axis of symmetry, right? It goes right down the middle. Well, when we do parabolas today, they will still have that axis of symmetry. Okay? So there's the axis of symmetry. And we know this point down here is often where a maximum or a minimum is. In this case, it would be a minimum. And we know that that point down there is called the vertex. So we will still have the vertex in this lesson today. But unlike your previous lessons, this lesson will talk about what's called a focus point. And so this here is a focus point. And the rest of this chapter will talk about focus points. Ellipses have focus points. Hyperbolas have focus points. And if you have an eye, I think most of you guys have an eyeball, the lens on your eye is parabolic. And so you also have a focus point, and that focus point is often projected onto the back of your retina. And that's why an image comes up there. And then you have optic nerves that translate that image in your brain and it tells you what you're seeing. That's quite fascinating in a way. So parabolas have focus points. Now if this were a mirror instead of a lens or something like that, let me just give you an idea of what would happen. The rays that come from outer space or from the wherever would come in and they would bounce off and they would come through this focus point. And it's quite fascinating. No matter how they come in and bounce off, they'll eventually go through the focus point. And that's why it's called a focus point. Another amusing thing about it is that if this is a light bulb and it's placed at the focus point, then all the rays that bounce off the mirror would go parallel. Now that's amusing. Doesn't matter how it goes, hits here, it goes parallel. All of these light rays would go parallel. And so sometimes you have seen these, like in Batman movies, they have a parabolic mirror with a light source, and that's why there's this light that shines straight like this. It's a big parabolic mirror like this, and it's shaped like this. Now those of you that have cars, if you go out to your car and look at your headlights, they almost all have a parabolic shape inside there, and you want your light in your car to be parallel because it goes straight down the road that you're driving. Does that make sense? Fascinating stuff. But you know, another thing that a parabola has, we're going to find out about this, it has this strange thing called a directrix. There's this line that goes behind here. Every parabola has what's called a directrix. And we're going to find out about that also. Okay, so it has this directrix. And so it turns out that there's a relationship between the parabola and the directrix. So we're going to find out about that. So let's get started on today's lesson. Amazing stuff. Okay, so we're going to learn how to graph and write parabolas. So I gave you a handout. We'll do some of the study guides together, but you also have to use graph paper, so I'll pass that out here in just a little bit. Lesson 8.2. So our objective today, students will be able to graph and write equations of parabolas. How do you write the equation of a parabola? Well, we've already seen two ways, but we're going to learn actually a third way. And they're all kind of related in a sense, except for what we're going to want now is to figure out where the focus point is. And we're also going to want to know where that directrix is. It gives us some key pieces of information. So, did you guys see that?
No, yet.
Let me back that up. I did this animation here for you. I mean, this is really hard work. That went in the shape of a parabola. Yeah, do it again. Okay, one more time. All right, watch. It's going to take the shape of a parabola. At least that's what I was trying to do. All right, so there's subliminal messages in my PowerPoints here. You know, you don't get this in any other place except for here. So here's some graph basics. Okay. So in the past we talked about standard form, vertex form. But today we're going to talk about a focus. And here's the thing, the focus is always on the axis of symmetry. Always. And the directrix is always perpendicular, and it's a line that's perpendicular to the axis of symmetry, and it's always kind of below the parabola, unless the parabola is opening down, and then it's above it. But you'll get the idea. So here's a little connection here. And this is why we want to know where the focus and the directrix is, because the distance from the focus to the parabola is equal to the distance to the directrix to the parabola. And this is quite amusing. So on the next slide, we're going to see some equations. Okay? And so where does this equation come from? We're saying x squared is equal to 4py. And there's a vertex at 0, 0. Let me just show you something real quick. I'm going to try and go through this real quick. Where did that equation come from? So I'm going to try and draw a graph of a parabola here. And I'm going to place the parabola right now. It's going to be stationed at the origin. And it's going to open upward. Like this. You see that? It opens upward. Now, in this case, the axis of symmetry is this y-axis. And so this point here is 0, 0. And the focus point would be somewhere inside the parabola. Everyone understand what I mean by inside? Yeah, it's kind of on the inside. Okay, so it would have the coordinates. What would the coordinates be? The x-coordinate would be 0, right? And we're going to call the y-coordinate, I'll just call it P for right now. Okay. Well, it's going to be where the focus point is. Now, there's this directrix underneath here. And it's quite fascinating. The distance from here to here, this will be like an arbitrary point. This is my arbitrary point on my parabola. What we're saying is that that distance is equal to this distance right here to here. Now I know in my drawing I haven't drawn it quite accurately enough. It doesn't look that way yet. But that's how you could define a parabola. This distance is equal to this distance. Well, yesterday you learned about the distance formula, right? So we learned how to do the distance, right? So if those two distances are equal, let's see what happens. Watch. What's the distance from here to here? Remember, you guys did this yesterday. So the distance from the focus to, I'm going to put a comma here, to the parabola, we'll call this, what do we want to call this, letter P. the distance from the focus of the parabola, it's equal to the square root, right? It's equal to the square root. Remember what you have to do? You have to subtract the x coordinates, right? So if I subtract the x coordinates, I get x minus 0, and then I square that. And then I take the y coordinates and I square that. I'm going to go plus y minus p, and I have to square that, right? Everyone okay with that? So that's the distance from here to here. What about this distance from here to here? Okay, so again, what I'd do is I would have to subtract the coordinates. So now here's the thing: if we take a point here, how do I find the coordinates to that point down there? The coordinates down there are not 0. Let me get my eraser out here. Remember what I said though is that if we look at this distance and this distance here, those two distances have to be equal, because it's the distance to the focus point. The distance to this line down here has to be equal, and so the coordinates right here are 0p. Well, that means this y coordinate is like this would have 0, negative p. Okay, and so the y coordinate would always be negative p, so the x coordinate would be whatever, and so I'd have x negative p here. That would be the coordinates if I picked an arbitrary point on this line. And so this is quite fascinating. Watch what happens. The distance then, the other distance, this is the distance from the parabola to the directrix. I'll use this notation. It's equal to square root of x minus x squared. And then I get plus, I get y minus a minus p. And then I have to square that. Okay? Well, what we're saying is that these two distances must be equal. So those two must be equal. Now check this out. I'm going to use my big eraser. I'm going to show you something that happens here. And I think you'll be amused by this. You don't have to write all this down. I'm just going to show you something. If these two are equal, then what I have is this over here. X minus x squared plus. Now notice I have a minus minus here, right? Isn't that the same thing as adding? That's really a plus sign then. So what I have is y plus p here. And so these two distances must be equal. So what I'm going to do now is just erase some junk. And now I have an equation here to play with. Well, notice I have a square root on both sides. Couldn't I just square both sides? If I square this side and I square this side, what happens? Well, the square cancels the square root, right? So this cancels off, the square root is gone. This cancels off the square. Now let's look here. This is x minus 0, so that's the same thing as x squared. And then I have plus y minus p squared. Now what's x minus x? That's 0, right? So that's 0. And so then I have y plus p squared here. Now notice what happens here. If I were to multiply this out, you guys should know the difference of what happens when you square this. You're going to have a y squared. This is a common pattern. Minus 2py. And then you have plus p squared. So that's if you FOIL this all out. And that's a pattern that we know already, right? Everybody knows that? Well, if you square out this side, it's very similar. You end up with a y squared, but you get a plus 2py, and then you get plus p squared. Want to get that? And you're going, where are you going with this? Now just watch what happens. It's going to come out very beautiful here. You know? Watch. Couldn't I subtract y squared on both sides? And what happens? they disappear. And can't I subtract the p squared on both sides? And they disappear. And couldn't I move this 2p to the other y to this other side? I'm going to add 2py over here, and I add 2py over here. And so I end up with x squared is equal to 4py. There you go. Now what's nice about this beautiful equation is that it has the distance to the focus point right there. This p is the distance to the focus point from the vertex. Let me go back to my picture here. What I had drawn for you before, please note this, is I had a parabola drawn right here, right? And I had the focus point was right here. Here's our capital F. And this distance here is p. And it's the distance from here to here. So what it means is that when we write the equation in this form here, we can find the focus point real fast. And consequently, we could actually find that directrix because this is negative p down here. And so then we just draw our parabola. Okay, so that's kind of where these equations come from. So now let's go back to the lesson. And I gave you a handout here. You have a handout that summarizes this information. But now you can understand where I got this equation. I just derived it for you. X squared is equal to 4py. Now parabolas of this sort will either open up or down. How do you tell if it opens down? You'll have a negative here, right? And so, but notice that we have the focus point is 0p, directrix is at negative p. Okay, so whatever this distance is, remember, the distance to the focus is equal to the distance to the directrix, always, no matter where you're at. So if you go over out to here, this distance is equal to this distance. And that's an amusing fact. And that is, in fact, how you draw parabolas. If you were to make a parabolic table, you would have to do it by doing this, more than likely. Or if you made a parabolic dish. You're going to learn about your TVs, why they use satellite dishes that are parabolic. You're going to learn that. It's because they have a focus point. Fascinating stuff. Okay, so let's get more into this because there's more fascinating stuff. We got to learn how to graph these. Now, in the previous chapter, chapter 1, we did not have any parabolas that opened up left or right. But all we need to do to open them left and right is switch the variables around. So you'll notice now the equation is y squared is equal to 4xp. Look at the previous one. It was x squared equals 4. Do you see the difference? Now you have a handout where you have both of these equations. And so if parabolas open left and right, they look like this. Y squared equals 4xp. And so now you have the parabola that opens left and right. So in this chapter, we'll see parabolas opening left and right and up and down. And you have a cheat sheet that kind of has this information on it. And you will use this cheat sheet to help you. So I will demonstrate now. This is also your cheat sheet. These are the two forms right here. You have x squared equals 4py and you have y squared equals 4px. The focus will be at 0p. The focus for the left-right one will be p0. The directrix equation will be y equals negative p. This case here will be x equals negative p. So this is all key information and it's all on your sheet. Now, let's try a graph. Again, these are the papers I gave you. And now let me show you how you graph one of these in practice. Okay? Make sure you pay attention on this example because it will make life a lot easier once we get this. Alright. Now, the equation we just talked about said y squared is equal to 4px. That's the form that's on your sheet. You see that? So if we want to find out where the focus is, what we need to do is figure out what p is. And so this is our equation that we start off with. The question that you want to think about is there a way to rewrite this so that there's a 4 out in front? Does that make sense?
Yes.
All right, so let me show you what I have in mind here. I'm going to erase this real quick. My plan is to rewrite this as y squared is equal to 4 times some number times x. Now, what number would that be? 5, right? So that identifies for me, now that I have this 4 here, that it tells me that that is my p. P is equal to 5. So here's what I know. Oh, by the way, does this parabola open up left or right?
Left.
You sure?
Right.
What's your sheet say?
Yeah.
If you have y squared here, it opens up along the horizontal axis, right? So this has a vertex right here. You guys okay with that? And there's a focus point right here. This is my focus point. Now, at this point, I know the parabola kind of takes this shape here. Okay? But I need one more point. Does that make sense? So, to graph the parabola, just like we did in the past, I need to get at least a couple points on there. So, there's a couple ways you can do this. You can just pick some x's or y's and find out some extra points. So here's what I recommend. You can pick a value for x and then you can find out the y coordinates. So check this out. What do we want to do? We want to, like, maybe we could pick like x equal to, now you guys look, if you look ahead here, you can make a good guess as what number we should try. Right now we have 20 in here, right? What would be a good number to take a square root of? You see, you have y squared here, right? You could take the square root of 4, right? The square root of 4 is equal to 2, right? Square root of 16 is equal to 4, right? You know that one. If I have 20 already, what number could I multiply by to make it a perfect square? All right, I'll tell you the first one, okay? How about if we make it 100? Yeah, so in other words, if I make x equal to 5, then what do I have here? I have y squared is equal to 4 times 5 times 5 again, and that would equal 100. And so then I have y squared is equal to 100, right? And so then I take the square root here and the square root here, and I get y is equal to plus or minus 10. Does that make sense? So when x is equal to 5, that's the location of our focus point. The y coordinate would be plus or minus, plus or minus 10. You see? And so now I know this parabola kind of goes out like this and passes through that point and goes that way and passes through this point going this way. Okay? And once again, there is an axis of symmetry that goes through this way. Alright, now this distance here is what we call P. That's the distance from the vertex to the focus point. And you often want to know where the focus point is because that's where you either want to have a filament for a light or sometimes where you want a receptor to receive rays that are coming in that are bouncing off. Like your satellite TV, that's where that receptor is sitting at. So that all all the communication that you're doing with cell phones or with TV signals are coming in and bouncing in and going to that receptor. Does that make sense? That's the idea. So there's a couple things we want to be able to do. We want to identify the directrix, and we want to identify the axis of symmetry, and we want to identify the focus. Are you ready? We have everything right now. So the focus point. You guys ready? Well, it's equal to what? The x coordinate is 5, and the y coordinate is 0. Okay, so that one's done. Bam. How about the axis of symmetry? The axis of symmetry is basically the x-axis. So the axis of symmetry is the equation y is equal to 0. That's the x-axis. Okay, so we got the axis of symmetry, we have the focus. Now we need the directrix. Well, the directrix is going to be 5 units this way. So the directrix is going to be 1, 2, 3, 4. It's going to be right here. And it's always perpendicular. So what you will have when you're drawing the vertex or the directrix, I'm going to try and get this drawn in. Try to draw this good. This is a little tricky with these tabs. You'll have a line that looks like that. This here is the directrix. Okay? Now what is the equation of that line? Well, that's a vertical line. So the directrix, I'm going to say, is equal to x equals -5. That's the equation of the directrix. Now if you have your cheat sheet, it kind of summarizes all this information for you. So what we need to do is maybe 2 or 3 more of these so you get the process down, because it can be tricky. But take a good look. We have the focus, we have the axis of symmetry, we have the directrix, and there's our parabola as a focus point. Okay, I think we better do another one. Alright? Now this one. The first thing you want to realize, I think, is to realize whether it goes up or down or left or right. So can you quickly look at your cheat sheet and figure out which way does this one go? Up, down, or left or right? You have x is equal to -1/8 y squared. You guys have this? Down. You sure? Okay. You have the cheat sheet. Look on your cheat sheet. You have the parabolas open, down, up, left, or down on it, right? Well, the negative will make it go either down or left. But is this a left, right, or is it an up, down type parabola? You sure? All right, let's go back, because I don't think you guys have this figured out yet. Now, hang on. We have x is equal to -1/8 y squared, right? All right, so let's go back right here.
This one. I was looking at this one.
Don't we have an x equal to a y squared? Right here? Does this parabola open up or down? This goes left or right, doesn't it? Look, didn't we have on our equation, we had x is equal to -1/8 y squared, didn't we? So take a look. Isn't this x squared? Well, we have a y squared. You see? So when you have x squared, it opens up and down. When you have a y squared, it opens left or right. So this one opens left or right. Now how can you tell which way it opens?
Negative.
It's negative, so it means it opens left.
Right.
Right. so you got all right, so we're right here, right? So based on just looking at this setup here, opens left. Okay, I say it opens left because of that negative. All right? Now, I'll tell you a little secret. You guys want to know a secret? I'm going to tell you a secret how I keep these straight in my head. Okay? You know the equation I know by heart is this one. Y equals x squared. Okay? That one I know is from the previous chapter. That was the parent function. Remember we studied the parent function? That was the one I've known for years and years and years. I know that one is the one that opens up and down. So if I don't have y equals x squared, then I know it's a left-right one. Does that make sense? And I had y squared instead of the x squared. So that's my little secret. All I do is I know, okay, hey, I know the parent function for this guy. I know this one for, we've done it. And if it's not this form, it means it's the left-right one. And that's how I remember myself. And then the negative makes it easy, right? It goes left. Okay, so this time I know the vertex starts off right here. I know there's a focus point this way. And I know there's a directrix over this way. How do I find the focus point? Well, that's the tricky part sometimes. Sometimes you have to be absolutely clever to do this. So you got to pay attention. Emmanuel, you got to pay attention. All right, watch. The correct form is I'm looking at something like this. To figure it out, I need x is equal to, well, don't I need like, wait a second now. What is that correct form for this setup here? Is this written in the right form already?
No.
What should it look like?
Y squared.
It should, what it should be, the correct form that I'm looking at on my cheat sheet. Okay. If I'm understanding my cheat sheet correct, it says something like this. It says y squared is equal to 4px. Does that make sense?
Yeah.
Is that what you have on yours? Okay, so what I want to do then is maybe some basic algebra. I got to get rid of this 1/8 then because the y squared is by itself. So why not get rid of, what I can do here is just, I'll just multiply this side by -8. Okay. Now multiply this side by -8. Okay. And so this 1/8 will then cancel off with this -8. And that'll give me y squared is equal to -8x. Now is there a way that I can somehow get a 4 written out in front? Not divide by 2. How about if I write it this way? I'll put the 4 there first. Then I'll figure out what to multiply by. I need a -2, don't I? I need a -2 right here. You see what that does though? By writing the 4 out in front here, it identifies what the focus distance is. It identifies what your P is. So where's the focus? It's right here. There is my focus point. Does that make sense so far?
Yeah.
It says it's -2. So from the vertex I go over -2. Now, I can go the opposite direction and I can find out, well, hey, there has to be a directrix right here then. Now let me try and draw this in. The directrix is right here then. Oh, why is my stupid thing grabbing? Oh. I have to try and draw this. It keeps going back to the eraser for some odd reason. Holy cow, this is ticking me out. Okay, so I'm not on the eraser anymore. I'm on the pen. Now stay on the pen, Dumpty. Holy cow. Okay, I've erased it, but maybe I should go to my highlight. Oh my goodness. I don't know, modern technology, you could see it effing up right now. It's supposed to be on the pen. Oh, maybe what happened is okay, let me turn on my thing again. Must have touched the screen somehow. Okay, let me fix this. Give me a second. Alright. Alright. Now it's working. So there's my directrix. And the thing is, I can't draw very straight freehand. There's my focus point right there. There's the vertex. Okay, so I know this parabola opens left or right. Right? So here's my focus. What do I do to find a point? Does only one person know? Negative 8x, right? I need to pick an x that will hopefully be a nice square root. Because, see, I'm going to be taking a square root here and a square root over here, right? So why not pick an x that's going to make a perfect square over here, right? Why not use negative 8? Does that make sense? So I'm going to choose negative 8 right here because negative 8 times negative 8 is 64. So then I have y squared is equal to 64. Alright, make sense what I'm doing? And so this would give me y is equal to plus or minus 8. So when x is equal to 8, negative 8, that's over here, then the parabola is at positive 8 and negative 8 right there. So my parabola goes like this. You see? And there's the focus point. And there's the directrix. So notice that this distance here is 2. And that distance there is 2. So now we want to go through our list of requirements. We want to, where is the focus? Where is the directrix? Where is the axis of symmetry? Okay? So I need to get an eraser so I have some room to do this. Well, the directrix is this line behind it. And I'll go over here in just a second. But let's write down what the focus point. The focus point. Isn't it at negative 2, 0? And where's the axis of symmetry? The axis of symmetry this time is this line going down here in red, right? It's right here. What is the equation of this? Well, the axis, I'm just going to abbreviate. The axis, okay, is y equal to 0. And so there's our axis, there's our focus. And where's the directrix? The directrix. The directrix is going to be x equal to 2. So there you have it. We found all three. The axis, the focus, and the directrix. And there's our beautiful graph. So you're gonna go through the sequence of steps every single time. Now, what's kind of cool, and I hopefully can draw this in here, this distance is equal to this distance. That's the relationship between the focus, the parabola, and the directrix. The distance from the focus to the parabola is equal to the distance to the parabola to its directrix. Always. So same thing, if you go clear out here, that distance is the same as this distance. Does that make sense? No matter where you go. That's a very interesting relationship. And you're going to see, we're going to talk about ellipses pretty soon. Like on Thursday, we'll start talking about ellipses. But they also have these special relationships, certain distances. And that's why we started off the chapter with the distance formula, to remind you how that all worked. Okay, so what I want you to do for tonight, okay, we only got a few more minutes. I want you to work on your study guide, and I want you to do the first four. The first four on your study guide. All right?
You have to make the x and the y squared on the last two, right?
Well, you want to use your cheat sheet, and if it's written in the correct form, you can still do that. Now, let me just show you something. Let's look at your study guide number 1. Okay? I'll help you get started on it. Hello, Miss Russell. Nancy Sanchez, you need you in the office. Okay, that's like the 4th interruption I've had this period. It's like ridiculous. Okay, so the first problem on your study guide is y is equal to what? Excuse me. It's x squared. X squared is equal to 1/4 y. Right? Now, what's it say on your cheat sheet? What is this supposed to look like? Guys, pay attention or else you won't get this.
I know, pay attention.
What you want in order to find the focal distance is you have to rewrite this with a 4 in there somehow. So you have to be clever. 4 times what number times y would be the exact same equal expression up here? What number can we multiply by? Well, in this case, it would have to be 1/16. Does that make sense?
Yeah.
Because what's 4 times 1/16? 1/4. You see? So sometimes you have to be clever to figure out what the focal distance is. But the nice thing about having that 4 out there is once you get the 4 out there, you know that this distance then is your P that you're looking at. That's the focal distance. And so this parabola, unlike the previous ones, the focal distance is right next to the vertex. So if you're looking at the graph on this one, the vertex is right here, and the focus is like right next to it. And you're going to notice something different about this graph. This graph is going to be, you notice the first ones we did were very spread out, right? Like this. Well, when the focus is very close to the vertex, it does something different. And so you'll have to discover what that is. Anyhow, that's your focal distance. And so the directrix is also 1/16 this way. And so, oh, by the way, does this open up or down?
Open. Side to side. Up.
Didn't I tell you before, like the one that I have memorized, y is equal to x squared? This opens up or down. There's your y, there's the x squared. So this opens up or down. It's not a left or right one. Okay? So you guys are going to have to get used to this new type of equation and try, like I said, to do the first 4. I have to stop this now.